Good morning, guys. Today we're going to look at quadratic inequalities. We're going to look at how to graph them and how to solve them. Very similar to linear inequalities, just have a quadratic curve, have a parabola instead of a straight line. So let's go through and look at graphing first. We have this example here. F of x is greater than or equal to x squared plus 2x minus 8. So we're going to graph the same way we would graph any quadratic, whether it's an equation or an inequality. And we're going to look at what type we have. This is in standard form. So in a standard form quadratic, we graph by finding vertex and intercepts. So let's start with the vertex. I know the x coordinate comes from negative b over 2a. So there's my a, there's my b. So negative 2 over 2 times 1. Negative 2 over 2 is negative 1. The y coordinate we get from plugging the x coordinate in. So negative 1 squared plus 2 times negative 1 minus 8. So we're going to get 1 minus 2 minus 8, which equals negative 9. So there's our vertex. Negative 1, negative 9. Let's go through, let's find the y-intercept. We remember that the y-intercept is just the constant. Remember 0 for x at your y-intercept. So the y-intercept is going to be 0x and negative 8 is left over. Remember, just plug 0 in for your x's. For your x-intercept, we take our function x squared plus 2x minus 8, set it equal to 0 and solve. This one will factor. If you don't recognize that it factors, you can do your discriminant, check and see. B squared minus 4ac, and we get a perfect square, so we know it'll factor. So negative 8 is negative 4 times positive 2. Negative 4x plus 2x is the negative 2x, is not negative 2x, so if you need to change your sign, change your signs. So positive 4, negative 2, positive 2x. So good thing I checked that one. So we go through, we factor, set each factor equal to 0. So move your 4, move your 2. So x is equal to negative 4, x is equal to positive 2. Now we're ready to graph it. We just put all this information on a graph. So vertex is at negative 1, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Y-intercept is at 0, negative 8. 0, negative 8. X-intercepts are at positive 2 and negative 4. And we can see that that should check out because our x-intercepts are 3 units to the right of the vertex and 3 units to the left of the vertex. So it looks like all these calculations were done correctly. Now when we connect the dots, it's like any other inequality, got to check solid line or dotted line. Well, this says greater than or equal to, so we're going to go with the solid line on all of those. Remember, you're always labeling your points just to make sure we've got them. Negative 1, negative 9, 0, negative 8, 2, 0, negative 4, 0, and so on. Solid line because it's got the or equal to. Now we do the shading, just like all other inequalities. Greater than for a y equals, which is what f of x is. Greater than for a y equals, we want the greater y's, so we shade above. If it had been less than, we would have the lesser y's, we would shade below. So above this graph is going to be on the inside of this graph this time. If the graph was turned over, above would have been on the outside of the graph. So above is the section of the graph that includes positive infinity, which is the inside portion here. It's going to keep going up here. So positive infinity is going up, so we're going to shade everything inside on this one. So that's the graph of this inequality. If you'll go through, pause the video, take a couple minutes, try to get the graph for number 2 right up here. Y is greater than negative 2x squared plus 4x minus 3. And I will wait right here while you all take a crack at that one. So hopefully you've been able to get the graph for this one. Let's go through and check your work. First thing we're going to do is find vertex, because again we're in standard form. So take your vertex, make sure you put the E in the word vertex, the second E. We know x is equal to negative b over 2a. Well, there's a, there's b, so that's negative 2 over 2 times, let's try that again, negative 4 over 2 times negative 2. So we're going to get negative 4 over negative 4 is positive 1. Now we want the y coordinate by plugging that in. So negative 2 times 1 squared plus 4 times 1 minus 3. 1 squared is 1, so that's negative 2. 4 times 1 is 4 minus 3. Negative 2 and negative 3 is negative 5 plus 4 is negative 1. So there's our vertex, 1, negative 1. Now we want the y-intercept. We know the y-intercept comes from just taking your constant. If I didn't have a constant, so I just had this right there, then the y-intercept would have to be 0, because there's 0 constant. So y-intercept is going to be 0, negative 3 on this specific problem. And then x-intercept, take your function, set it equal to 0 and solve. This one doesn't look like it'll factor, so I'm going to try quadratic formula on it. If it does factor, then it'll show up in the quadratic formula solution anyway, so let's just try it with quadratic formula. Negative 4 plus or minus square root of 4 squared minus 4, negative 2, negative 3, all over 2 times negative 2. Remember, negative b plus or minus square root of b squared minus 4ac all over 2a. Clean it up. Negative 4 plus or minus square root of 4 squared is 16. 4, 2, and 3 is, what's that, 24? Yeah, 4 times 6 is 24. All over negative 4. So we're going to get, what's that, square root of negative 8. So negative 4 plus or minus 2i square root of 2 over negative 4. Clean it up. 4, 2, and 4 can all reduce by negative 2. So 2 plus or minus I square root of 2 all over 2. Remember, the negative cancel each other out. So at this point we can see, at this point we see that we got an imaginary x or intercept, which tells us that there is no x-intercept because these zeros are non-real solutions in this specific problem. So no x-intercept means we don't have to graph one. It's 2 less points we got to plot. Well, 1 less point we got to plot. So graph the y-intercept, or sorry, graph the vertex. Over 1, down 1. Graph the y-intercept, 0, negative 3. And since we don't have an x-intercept, we've still got to balance our function out. We need the right-hand side of it because it's symmetric. So if it was left 1, down 3, then we should go right 1, down 3 to get the other side of our graph. And that's just using that idea of symmetry. Greater than, we need a dotted line. Those of y'all that are yelling at me right now, I knew that was there. So, greater than on that one. And now we want to shade where? Greater than we said before, we shade above the graph. So above the graph on this one is going to be the outside portion of this function. You can shade all you want to. Okay, so that is the graph of that inequality. Give me a moment and I'll get up some inequalities that we're going to solve instead of just looking at the graph. So here we have the steps for solving a quadratic inequality, very similar to solving a quadratic equation. First thing you're going to do, rewrite it in standard form, so get it equal to 0. Then you just solve. So you solve either by factoring, by square roots, by quadratic formula, by completing square, whatever technique you want to solve that quadratic, solve that quadratic. When we solve, we're finding what are called the critical values, and that's where we change from less than to greater than and all that stuff. That's where the inequality stuff starts to come in. Once we have those critical values, we're going to determine the solution intervals, because remember, an inequality doesn't have a single number as an answer. It has either greater than or less than numbers for an answer. So we have those intervals for our solutions. So we're going to determine the solution interval or intervals by one of two techniques. Either testing a point from each interval to see which one satisfies the inequality, or analyzing the graph of this function in standard form to see where that satisfies the inequality. So the way it'll work out is I'm going to get a couple of numbers, I don't know, could be anything, but say that I got -3 and +2 as my critical values. So if those were my critical values, I would just pick a point in the left interval, so something to the left of -3, in that middle interval, and then that right side interval. So I would just pick a point from each of them, and then you just plug them back into your inequality right here. And whichever point makes it true, then that's going to be your interval. Remember, write it in interval notation. We'll go over that here in a minute when we work some examples. That's the test a point technique. Some people call it the algebraic technique. I like looking at it graphically. So graphically, you would say my critical points are my x-intercepts, so we know that our graph is going to be, whether it's positive or negative graph, looking at A. If that's a -3 and that's +2. If my graph looks like this, just doing a quick sketch because all we need to see is above and below, then I'm going to look at, if still having these 3 intervals, which section of the graph satisfies the inequality. So if the inequality said greater than 0, 0 being the y-axis, 0 being the x-axis, which portion of the graph is greater than the x-axis? That's the middle portion, the middle interval. If on this one it said less than, which portion of the curve is below the x-axis? That'd be the 2 outside portions, or the 2 outside intervals. So you can kind of do it the algebraic technique, the test a point technique, or the graphing technique. I'll go over both of them with you. This is the one I prefer. I think it goes a little bit faster, but some people just like that one because it gives you steps. You just plug in numbers and let the numbers do the math for you. This takes a little more analysis, but it is a lot quicker. But you kind of just work your own preference on that. But we'll give me a minute, I'll get a couple of examples up here for us to try out. So here we have a couple of examples of inequalities we want to solve. So we start by getting it into standard form, just like we had talked before. So I'm going to move my 10 over. So I get x squared minus 7x plus 10 is less than 0. Let me just go through and solve. This one will factor. X squared is x times x. 10 is going to be -5 and -2. -5x, -2x is the -7x. Remember, I'm looking at equals right now because I want to know what those critical values are. So I don't need the inequality at the moment for when I'm doing this portion, when I'm finding the critical values. Set each factor equal to 0, x equals 5, x equals 2. So there's your critical values. So we have a number line now. And this is where you get into the 2 techniques. Tell you what, put it over here and I'll call this technique 1. Okay? We're going to draw a number line. Put our critical values on it. So I've got 2, I've got 5, and then just pick any number in the interval. So to the left of 2, the easiest number to work with is probably 0. Between 2 and 5, you can do any number you want. 3 is the first small, or is the smallest integer in there. So that's probably what I'm going to go with. In this one, I'm gonna pick 6. I could have picked 4.01327. I could have picked 6 billion here. I could have picked negative 47 kajillion. It doesn't matter what you pick as long as it's in that interval. If it works for one point in that interval, it'll work for every point in the interval. So then we test. So we go back to this step right here, and I'm going to test the 0, test the 3, test the 6. So plugging in 0, 0 squared minus 7 times 0 plus 10. Now that is supposed to be less than 0, because that's what our original inequality said when we solved it. We got it into standard form. That's supposed to be less than 0. Well, what's that equal? 0 and 0 plus 10 is 10 less than 0. No, it's not. So that interval is no good, because the number from that interval, and I could have picked any number in that interval and none of them would have worked. All right, let's try the 3 now. 3 squared minus 7 times 3 plus 10. We need that to also be less than 0. So 9 minus 21 is negative 12. Negative 12 plus 10 is negative 2. Negative 2 less than 0? Yes, so that interval checks out. And then try the 6. 6 squared minus 7 times 6 plus 10 is less than or equal to 0, or sorry, it's supposed to be less than 0. What's this end up equaling? 36 minus 42 is negative 6. Negative 6 plus 10 is positive 4. 4 is not less than 0, so that interval doesn't work. So there's your solution, the interval from 2 to 5. Now we want to write this, it says in interval notation. The way we write interval notation is we just do first number, comma, last number in the interval. First number, comma, last number. And then we're going to put either brackets or parentheses on that. Brackets or parentheses. And that's dictated by or equal to, or not or equal to. So that's a quick rundown of what interval notation is, and you'll see it show up in a lot of different texts. But this one, we were not equal, so we're not going to use the brackets, we're going to use the parentheses. So it's really as simple as putting parentheses around your numbers and throw a comma in there. So there's your solution using technique 1. So the interval from 2 to 5. Now let's look at technique 2. Technique 2 said do a quick sketch of the graph once you have your critical values. Losing another black marker. All right, so we know the x-intercepts are at 2 and 5. A was positive, so that means our graph goes up. And we want to know where is this graph, and that's the way we read it when we're doing technique 2. We're asking ourselves, where does the parabola below the x-axis? That's technique 2. The equation is the parabola, less than is below, 0 is the x-axis. So if we look at our 3 intervals, we still have the same 3 intervals. Okay? We're still going from 2 out here to the left, you can call that negative infinity, 2 to negative infinity, 2 to 5, and 5 to positive infinity. So in these 3 intervals, where does the parabola show up below the x-axis? Well, we can see it's this middle interval. Between 2 and 5, our parabola shows up below the x-axis. So between 2 and 5, this function has only values less than 0. So there is your interval from 2 to 5. We put parentheses instead of brackets because it's less than instead of less than or equal to. kind of like open circle versus closed circle, but when you're comparing parentheses and brackets on your interval notation. So I like technique 2, takes a little analysis, but technique 1 is good if you think you'll mess up your graph or any of that stuff. You can just plug numbers in and say, are we less than or greater than? All right, let's look at number 2 right here. So we start by getting it in the standard form. Move that 15 over. So 2x squared plus x minus 15 greater than or equal to 0. Just solve now. Now this one will factor. Also, 2x squared is 2x and x. Negative 15 is going to be plus 5. Nope. Minus 5 and plus 3. If you check it, negative 5x plus 6x gives us the 1x that we need for the center. All right, so we've got it factored. Set each factor equal to 0 and solve. So add your 5, divide by 2, subtract your 3. Right, there's your critical values. So the solution will either be outside those values or between those values. Okay? So let's try technique 1 for determining our solution. Go with your number line. So we're at negative 3, positive 5 halves. Let's pick some points to the left of negative 3. I'm going to go negative 4. Between these two, I'm going to use 0. Any interval that has 0 in it, I'm going to pick 0 for that interval because it's the easiest calculations to do. Between past 5 halves, which is 2.5, we'll go with 3. And then we just test it. Test the negative 4, test the 0, test the 3. And remember, we're trying to get it to be, you can either test it here or here. It doesn't make a difference. I just work off of here. So we want it to be greater than or equal to 0 on all those. Or we want to see which ones have it greater than or equal to 0. So we have 2x squared, so 2 times negative 4 squared, plus x, so plus negative 4 minus 15. So we're just taking these 3 test points and plugging them back into the x's of our original function. Okay, just plugging those in there, seeing what it equals. So negative 4 squared is 16 and 2 is 32. 32 minus 19, 32 minus 19 is 13. Is that greater than or equal to 0? Yep, so that interval works. Let's try the 0. 2 times 0 squared plus 0 minus 15. Well, 0 and 0 makes negative 15. Is negative 15 greater than or equal to 0? No, it's not. So we know that middle interval is not going to work. And try the 5 halves. 2 times 5 halves squared plus 5 halves minus 15. What's that equal? 5 halves squared is 25 fourths. 2 times 25 fourths is 25 halves. 25 halves times 5 halves is 30 halves, which is 15. 15 minus 15. Oh, that's why it equals 0. Duh. Supposed to be plugging in a 3, not a 5 halves. Obviously, it's going to work at 5 halves because we already said that that equaled 0. Should have spoke up a little louder. I'd have caught it sooner. 3 squared is 9. 9 times 2 is 18. 18 and 3 is 21. 21 minus 15 is 6. So that interval also works. So since outside intervals work, we're going to work all the way to negative infinity and positive infinity. So I just need this outside, so put a comma between them. And since it has the or equal to, we put the bracket on it. Now, a little thing that we need to pay attention to is infinities always have to get parentheses. And the reason infinities always get parentheses is because you can't ever actually equal infinity. So it's just the actual real numbers that we will be able to put brackets on when we have an or equal to. So our solution would look like negative infinity, well, we hope it looks like negative infinity to negative 3, union 5/2 to positive infinity. So that should be that is the solution. So any number picked out of those intervals will satisfy this inequality. All right, let's look at that same thing except using technique 2. So technique 2 says do a quick sketch of your graph. X-intercept at negative 3, or other x-intercepts at 5/2. A is positive, so our graph is going up. We have our intervals. So, and you can go ahead and label the negative infinity to positive infinity on there. All right, so we want to know where this graph is greater than 0. Oh, I erased it all, didn't I? 2x squared plus x minus 15 greater than or equal to 0. Remember how we read that? This says the parabola greater than means on or above. 0 means x-axis. So we want to know which interval has our graph, has our parabola on or above the x-axis. Well, we can see that this middle interval, we're actually below the x-axis. So we know it's not the middle interval. But we can see that on the left side, this left interval, our parabola is above the x-axis. The right interval, the parabola is above the x-axis. So we can see that from negative infinity to positive 3, bracket because it's or equal to, and then from 5/2 to positive infinity, we get a graph, part of our parabola is above, on or above the x-axis. So that's the graph technique, that's the pick a point technique. Both of them get you to the same solution of negative infinity to negative 3, along with 5/2 to positive infinity. That union just means a number from either one will satisfy the inequality. Okay. Give me a second. I'm going to get 2 more examples up here for you guys to try. And we'll see how you guys do. Here you go, guys. I've got 2 examples up here for you. I want y'all to pause the video, take a couple of minutes, and see if you can come up with the solutions to each of these quadratic inequalities. And I'll wait right here. So hopefully you were able to come up with solutions for each of these. Let's go through and check your work. If you got the second one, that's really good because it's got a little twist to it, but we'll go over it. Number 3 right here, we've already got it in standard form, which is good. We want to go through and solve, so find those critical values. So this one, if you go through, it should factor, assuming my arithmetic is correct. Negative x squared is negative x times x. 4 is going to be minus 1 and minus 4, right? Because that's negative 1x plus 4x gives us the positive 3x we need for the middle. All right, so it factors. We then go through, set each factor equal to 0. So negative x minus 1 equals 0, move your 1. Actually, you can just move your x. So negative 1 equals x. X minus 4 equals 0. Move your 4. So x equals 4. Now let's go through, we've got 2 techniques. So technique 1, we'll do it over here. So we've got our number line, negative infinity, positive infinity, -1, +4. So there's our 3 intervals. Pick a point out of each interval. So -2 works for me, like 0 there, 5 there. But as you can see, if you pick different points, you're still going to get the same answer. Okay, so we just try them out. So I'm going to try the -2, the 0, the 5. Take your inequality in standard form. So -2 squared plus 3 times -2 plus 4. And that should come out to be a number greater than or equal to 0. -2 squared is 4. Negate that, so -4. Remember, exponents before multiplication. So -4, -10, and then -4 and -6 makes -10, plus 4 takes us back to -6. Is -6 greater than or equal to 0? No. So that interval doesn't work. 0, we try it. So -0 squared plus 3 times 0 plus 4. 0 and 0 and 4 makes 4. Is 4 greater than or equal to 0? Yes, so the middle interval works. And then we'll try the 5, even though we know that it shouldn't work at this point. But let's go through the semantics, or through the ritual. We'll just finish out the process. 3 times 5 plus 4, -25, right? 5 squared is 25, make that -25. Plus 15 plus 4 is going to give us -6 again. So -6 greater than or equal to 0. No, it's not. So that third interval doesn't work. So our solution is going to be from -1 to +4. And since it's over equal to, we bracket those. So there's the solution. Let's look at that same solution with technique 2. So if we do quick graph, -1 is an intercept, 4 is an intercept, there's -infinity to +infinity. From there we see A is negative, so this graph would go down. So when we look at our 3 intervals, the interval to the left of -1, the interval between -1 and 4, and the interval to the right of +4, we want to know where is this graph. And that's how we write it. Where is the parabola or greater than or equal to means on or above. 0 means x-axis. So where is that graph, that parabola, on or above the x-axis? Well, we see that to the right and left, we're below the x-axis, so we know it's not them. It's this middle portion, right here, between -1 and 4. Between -1 and 4 is where we are on or above the x-axis. So there's our solution. From -1 up to 4, and we bracket it because it had the or equal to. Now, no, you don't have to do both techniques. I don't care which technique you use, whether you use the graphical analysis technique or whether you do the test of point technique. Both of them, if you do them correctly, will get you the same answer. And maybe it's good to do both of them just to double check and make sure you've executed correctly going through everything. But either technique will get you there. Now let's look at number 4 because it does have something different about it, where the graphical analysis technique makes it obvious what's going on, and the other technique you have to think a little bit more on it. So this kind of sets up why I like that graphical analysis, that technique 2, a little bit better because it kind of covers all the trick ones, I guess, the ones that have non-traditional type solutions. But let's go through and let's do the calculations first. So we take it, x squared plus 4 equals 0, because we're going to find the critical values. Only one x in the problem, so I can do this by square roots. move my 4, x squared equals negative 4, take square root, x equals square root of a negative is plus or minus 2i. Well, I can't graph plus or minus 2i on my real number line. So I've got the negative infinity, positive infinity. I have no critical values. So when this happens, for technique 1, there are no critical values, so my answer is either every number or no numbers. It's either going to work for all of them or it's going to work for none of them. So I'm just going to pick a point in my interval. This is my only interval right now, and that point I'm going to pick is 0 because it's the easiest to do calculations with. So right here, testing 0, 0 squared plus 4. 0 squared plus 4 equals 4. Is that greater than 0? Is 0 squared plus 4 greater than 0? The answer is yes. So my answer is negative infinity to positive infinity. Negative infinity, positive infinity. If it works for one point in that interval, it's going to work for every point in that interval. Well, let's look graphically at what's going on here. And technique 2 makes this a little bit more obvious, I think. So if I look at the graph, plus or minus 2i means there are no x-intercepts. A positive a means it goes up. So if it has no x-intercepts, it can't be below the x-axis and going up. So it's got to be up here somewhere. Really doesn't matter too much where. We just have to show it somewhere above the x-axis. So if we are negative infinity to positive infinity, and we ask the question, like we do when we're analyzing graphically, we ask, where is the parabola? Greater than means above the x-axis. So, in this interval, where is the parabola above the x-axis? And the question is, everywhere. Everywhere in this interval, we have that parabola above the x-axis. Nowhere in the interval do we have the parabola ever go below the x-axis. So this right here, I think graphically makes it very obvious that the answer has to be your negative infinity to positive infinity. And remember, always parentheses on your infinities, whether it's got the or equal to or not. So we can do it with test a point, or we can do it without test a point. The graphing gives you a little bit more help on these special type cases when we don't have x-intercepts, or if we have only one x-intercept, meaning the vertex is on the x-axis. So there's some different situations that can come up there, and we will talk about those in class, but kind of be thinking about how you might get, or what might happen, what your solutions might look like if you were to only have one critical point. For example, say you had an x squared plus 6x plus 9 is, it doesn't matter, less than or equal to 0, something like that. You know, so when you do that one, you have your critical points are going to be negative 3. Go through factor x plus 3 because it's a perfect square trinomial. So x equals negative 3. So you only get one critical point in that case. So kind of be thinking about, and we'll talk about it when y'all come to class, about what is special about having one critical point versus having no critical points or two critical points. So that's kind of what I want to leave you with to think about before you come to class, and I will see you in class tomorrow, guys.